All right. There are two types of problems. Two types of problems on your worksheet / test. There's dividing and there's factoring. Now, here's how you need to study for this test. When I was in college, I didn't figure this out until like my junior year, but when I figured it out, it made studying a whole lot easier. Biggest thing you need to study, don't just stare at a bunch of problems that are worked. That doesn't do you any good. That's not going to stick. What you need to study are the directions and what the problem looks like. For instance, this problem, does it say divide or factor? Factor. On your worksheet, this is number 6, it says factor. So I'm like, okay, this is a factoring problem. If it tells me to factor and it looks like this, do I know what to do? If it says factor, what should immediately be your first step? What's the first step to any factoring problem? Not yet.
See what can come out.
See what can come out. What's the greatest common factor? Anytime your problems say factor, and this is what you need to drill into your skull. Anytime your problems say factor, your first step, does anything come out of this? Like factor out just by itself, like a 2 or an x? No. Step 2 to any factoring problem, and you should have written these down several times this week. Is it a quadratic? A quadratic is like x squared plus x plus 5. No, it is not. Step 3 to any factoring problem. Is it a square or cube? And I told you it'll be easier to tell because those will only be 2 terms. Yes, this is a square or cube. Which one is it? Well, of course, that's not working. It's frozen. There's a cube above the x, so it's going to be a cube problem. It's going to be a cube problem. So then you get out your formulas for squares and cubes. And yes, at this point, just use your stinking formulas on Friday. You can have them. I'll put them on the board for you. So, it's a cube because there's a big fat 3 right there. Is it a sum or difference?
Different. No sum on that.
It's a sum. It's the sum of 2 cubes. So, you should ask yourself, factoring, I've established that it's a cube. Do I know what to do? Once you've established that it's a cube, you should just look straight at your notes and say, what's the formula for that I've given you now multiple times this week? What is the formula for the sum of 2 cubes? Who has it in their notes?
A plus B.
A plus B.
A squared minus A times B plus B squared.
Very good. Now, when you're looking at this in your homework, you look at this. Once you've established that's what you need to do, you need to look and be like, do I know how to get this in this form? Do I even know where A and B come from? Where does A and B come from in words? Logan, can you tell me where A and B come from? I don't know why I picked you, but do you?
I haven't got that formula.
You should have that bloody formula. Jalen, do you have that formulas? Those formulas?
Yeah.
Can you give me a cue, please? Yes, sir. Yes, please.
Right, it's like that. I guess A and B is squared, others like A.
Exactly. Exactly. All of those squares and cube formulas, all of them. The A is just the first term, and the B is just the second term. So once you've established that it's just a formula, now, Caitlin did that, except the one thing she forgot is the one thing lots of people are forgetting, and that is that you have to write this as something cubed. What's the cube root of 64? 64 to the 1/3 power in your calculator. Enter. You'll find that it's 4. Now, once you've got your x and your 4, you shouldn't miss this. X plus 4, x squared minus 4 times x, plus 4 squared, which is 16. That's where that answer came from. This is the process of thoughts. Even if you don't work a single problem, you will not have any chance of getting these right if you cannot look at a problem and think, oh, that's what I'm supposed to do. So that's what we're going to talk about until we're all bored as all get out today, is we're going to look at problems and say, what are we supposed to do? What is the trick to this problem that's going to let me know what I need to do to it? We're going to be jumping around your worksheet. We're not going to do them in order. Because I don't want you to just get in the same pattern of, oh, we're factoring, oh, we're factoring, oh, we're factoring. I want to mix it up. Let's start with number 2. Number 2. Pamela, what do the directions say in number 2?
Divide.
Divide. Does it say factor? Anybody? Does it say factor?
Did you call her Caitlin?
I said Pamela.
Oh, I heard Caitlin. I heard Caitlin. That's why I answered.
I have to look.
It doesn't matter. Minute detail. You need one, don't you?
It's right here.
All right. It says divide. Now, the difference between a division and a factoring problem, they're going to give you two pieces. They're going to give you two. On ours, the problem is x to the fourth. Oh, jeez. That's not even working. That's fantastic. Plus 3x cubed.
Are you just writing the problem down?
Yes. Okay. That's your problem. I don't know why x to the fourth is so elevated. Now, there's two kinds of division that we've done. There's the box, where you put the opposite of a number in a box, and there's just where you can go divide one term by one term. How do you know which one to do? Corey, how do we know which one to do?
You start from left to
That
right.
18
Hold on.
is supposed to just be an 8.
What Justin said.
Thank you.
I think that's.
Well, it's supposed to be a plus.
Yeah.
It's just my board is so off it didn't connect. Plus 8. I know.
You should just write the problem on the chalkboard and then we can go from there.
Well, this is being recorded, and if I don't write it, it won't show up on there.
Is that a 4
Yes.
in that box?
How do I know? Answer my question.
Because.
Focus. How do I know whether to divide it using synthetic division or to divide it just going one term at a time? How do I know? I'm asking Corey. Yes, I did.
I think it just blew my mind a little bit.
Stop talking. You know because you're dividing by two terms. That's the kind of thing you need to be writing down. That's the kind of thing you need to study. How the heck am I going to know what to do on Friday when it tells me to divide? If you're dividing by two terms, then you're going to use synthetic division, which is that box thing, and we're going to work it out in just a second. That's what you need to know. Now, look at number 1. Are we dividing by two terms on number 1? Like x plus 2 or x minus 5?
Nope.
No, it's just one little 6x. If it's not two terms, are we going to do the box method on number 1?
Nope.
No. That's the kind of thing you need to know when you look at the problem. If nothing else, if you went home Thursday night, looked at this worksheet, because you're going to hold on to this, and this is just like the test, and be like, divide term by term, synthetic division, quadratic. If you could just do that, I'll be so happy. Because you'll at least have some clue about what you're doing on Friday. But if you're like, oh yeah, I see, he multiplied and he added, well, that doesn't do you any good if you don't know when to do it. So, dividing by two terms, you're using synthetic. And synthetic is what we're going to do now to solve this problem. All right. The opposite of that number goes in the box. So instead of negative 4, it's positive 4. If it was x plus 2, what would be in that box? Negative 2. And all of our coefficients go on the top row. Aw, too far. So, how many x to the 4th do we have? What's the number in front of x to the 4th?
Enough.
1. 1.
Good one. How many x cubes do we have?
3.
How many x squareds do we have?
30.
32.
I would-
30 with the backwards.
Negative
I'd
30.
recommend you just look at your own worksheet because it's hard to read up here. Negative 32. How many regular x's do we have?
8.
Yeah, it's just 8, isn't it? 8. And how many numbers do we have?
40.
Very good. Were we missing any terms?
No.
No, it's 4, 3, 2, 1, nothing. So, we're ready to go.
That was an example.
All right. Who remembers the first step to synthetic
Drag
division?
1 down.
Bring the first number, whatever it is, down.
And then you times that by 4.
Very good. Multiply. Yeah, see? That's the kind of light bulb I heard a lot last block. Oh, I know how to do that. Now that I know what I'm doing. I'm more interested in, do you know what you're doing? 4 times 1, 4. Add. 7. 4 times 7,
28.
28.
Negative 4.
Negative 4.
Negative 1.
No, you have to multiply. 4 times negative 4.
Negative 1.
Negative 12.
Negative
16.
4 times negative
That's what I
4.
put in the calculator.
Did you do divided or times?
Multiplied it.
It should have been
I
negative.
guess my calculator just had enough bit.
Negative 8. Multiply. Negative 32. and 8. You know what? Write that down, but then we're going to take a break from this problem for a second. We're going to go through every single problem. I'm going to show you what should be going through your head when you look at these. We're going to start at the bottom and work our way up. Number 9. What are the directions of number on 4 through 9? What are the directions? Factor. We're going to look at all of these, and I want you to write next to every single problem what you're going to do to solve it. And all we have to do is look at them to be able to tell. Number 9. What kind of factoring are we going to have to do on number 9?
I got one question.
Okay.
How'd you get to 4 again? Is it like,
It's the opposite of the number you're dividing by
alright, what number you're dividing by? Where you see that?
in the problem. Number 2. It's x minus 4.
Alright.
Opposite of that number. So, good question, Justin. On number 3, what will we be putting in that box? Justin?
Huh?
On number 3, what are we going to be putting in that box?
-3.
There you go. Now, number 9. Just looking at it, what kind of factoring are we going to have to do? No. I like that you're thinking about it. Right, what we did yesterday. Do you remember what that was called? By grouping. Number next to number 9, you should put by grouping. Now look at it. What makes it different than any other problem that we're factoring?
It got 4.
There's 4 of them.
Glad it doesn't have
That's
a
the
one.
kind of connection you need to make. How do I know we're doing it by grouping? Because there's 4 of them. Number 8, what kind of factoring are we going to be doing? By the way, your options are quadratic, grouping, or square or cube.
Square cube.
Square or cube, how did you know?
It's just 2.
There's just 2 of them. And it's a square because it's squared in the problem. Let's jump around. What about number 5? What do we do to number 5? What kind of factoring? Quadratic. And we're going to do examples like this, and you'll be able to do the work underneath it so you can see what kind of factoring goes with what. But just looking at it, you should be able to tell. What about number 7? Square or cube. There's only 2 of them. It's cubed. My challenge to you, and I can't make you do this, my challenge to you, go home tonight, a day before the test, look at this. If you can't look at these and be like, that's going to be quadratic, that's a square or cube, that's factoring by grouping, that's what you need to be able to do by tomorrow, if you're going to do well in this quiz. What about number 4? Quadratic. Because it's x squared, or in this case, n squared plus n plus a number. It's 3 terms. Anything we've done with 3 terms is a quadratic. Okay, the one we're doing right now, if you wanted to write this next to that, is synthetic division. Synthetic division.
Wait, that's number 2.
Yes. What's the other synthetic division problem on your paper?
3.
Number 3. Number 3 is going to be synthetic division. You're going to do this method on number 3 also. So write that next to number 3, synthetic division. Is number 1 synthetic division? No, because it's not x plus or minus a number. It's just one thing. Number 1, we're just going to divide term by term. You just want to write term by term, and we'll work through it in a minute. You'll be able to see what that is.
Are we going to finish this problem?
Yes, we are. I'm sorry. Yes, we are. We're actually almost done with this problem. This problem started with what? X to the 4th? Whenever you do synthetic division, you're going to come down exactly 1 power. So instead of x to the 4th, we are now at x to the 3rd. 1x to the 3rd. 7x squared. So you just go down 1 power of x every time. Minus 4x. Minus 8. Who remembers what to do with our remainder?
Put it over the x is or get some.
That's right. Put your remainder over whatever you were dividing by in the beginning, which I believe was x minus 4. That's what it says in your problem. So yes. You just use those exact same numbers and put it in front of descending powers of your variable. X to the 3rd, x to the 2nd, x to the 1st, no x remainder. That's the answer. That's it. That's what yours will look like on Friday. Again, that is synthetic division, which should be written next to your number 2. We're not going to do number 3 next. I want to space these out. But when we do number 3, it's going to look very similar to that, because it's the same type of problem.
I thought we put the 4 in there.
No, once we use the 4 here, we don't use it again. Okay, let's jump down to do a factoring problem. Let's see. Looks like we've got 1 by grouping, 3 square and cube problems, and 2 quadratics. We did a square cube problem as the DOM. So what do you say we knock out one of these quadratics? You want to do number 4 or 5? I don't even care. 4. Let's do number 4. By the way, at the end of the day for your grade, you need to have written down everything I've written down. I said that already. You were just talking. To Brooklyn? Be specific. Right.
I got it.
Good. All right. Number 4. Now, we've already written it down. We're going to be factoring this one with a quadratic, but you still want to go through all your steps. If you don't remember to go through your steps, you're going to forget the first step.
So what is this called?
Factoring a quadratic.
So just say quadratic.
Quadratic. Yeah, because factoring's in the directions. What?
Then it's on outside of the floor.
That's right. First step, what do these things have in common that I can divide out? 4. Very good. If I divide all of these pieces by 4, in squared, but yes, go on.
Can't read time.
4 divided by 4 is just 1n. 8 divided by 4 is 2. That still needs to be the first step in all your factoring problems. We took out what was common. We noticed 4 went into all 3 pieces, so we took it out and divided each piece by 4 to get what's
And
left.
then it's like, what could you times that equals like negative
Exactly.
2, and then what could you subtract?
Very good. Well, hold on a second. All quadratics, everything you wrote quadratic next to, will come into, now whatever you factor out is still going to hang around, but it's going to factor into something like this. Quadratics are the only ones that are going to factor like
They're
this.
both going to be n minus 1.
We're going to talk about that. Just give me 1 second. The only ones that are going to be these two pairs like this, where it's just n, are quadratics. All right. Now, what does this minus tell us?
They're opposite.
That they're opposite. One is plus, one is minus. If it was positive, then they'd be the same. What does the first sign tell us? That's right. That the bigger number is going to be the positive one. What are the only factors of 2? 1 and 2. This tells us the bigger one has to be the positive one. Does negative 1 plus 2 equal positive 1? Yes, it does. So plus 2 minus 1. And that bottom line is your finished answer.
Wait a second.
Yes.
How come
I
there
did
ain't,
mine backwards.
how
What?
come there ain't a number like outside here for their entities in between? What I'm talking about?
That's by grouping. That's what we did yesterday. That's going to be like number 9. That's a good question, though. That's a really good question.
Let's do one.
Let's do number 9.
Can we do number 5?
Yeah, number 5.
We have
We're
to
gonna-
jump around.
We're going to be doing like all of these. I don't want to do 2 of the same kind of problem back to back because I don't want you to just get into a lull.
If I do number 1.
There's only one of number. We're going to come back. I want to jump back and forth between division and factoring as much as possible.
Let's do number
We just did one like number 2, so let's do number 1. We haven't done one like number 1 yet. Number 1. Now it says divide. Now I've already told you how you're going to do this. Somebody raise your hand and tell me, how do I know that I'm not using synthetic division on this problem?
One time.
There's only one, and it's being multiplied, not added or subtracted. That's when you're going to do synthetic. I know I'm not doing that because it's only one term.
division.
That's right. Well, they're both division, but this is just regular division.
So then it's 2x squared,
Whoa, okay, so 12 divided by 6,
2x squared.
3x's divided by 1x. Remember, you can just subtract the exponents. 3 minus 1 is x squared. Go on, Justin. Plus 18 divided by 6 is 3. X squared divided by x is 1. Remember, 2 minus 1 is, and go on. That's right.
That's
You-
easy.
I'm glad you think so.
That's the answer.
Yes. You just do one term by term. 12 divided by 6, x cubed divided by x. 18 divided by 6, x squared divided by x. 24 divided by 6, x divided by x cancels. You will have one like that on your test. And it'll be the one that's not being, it says divide and there's no plus or minus. That's how you know when you can do that. Awesome.
Number 6.
We got time for one more for lunch. What?
6.
Yeah, we could do. No, 6
We've
was the
already
dom.
done 9.
6 was
I
the
want
dom.
to do 9.
Just 7.
You really want to do 9?
Yes.
But then we aren't going to have any more factoring by grouping problems.
Okay.
I'm fine.
Actually, we'll do 9 after lunch. Let's do 7 or 8.
Just 7.
That way we'll
Eight.
still have at least one of every type of problem.
8.
How about 8?
7.
Okay, let's do 8.
Yeah.
We're going to do them all. Number 8. Now, the directions. The directions say factor. So I'm not dividing, I'm factoring. Step 1. Is there anything common? Taylor, you asked for this one. Is there anything common? Nothing goes into either of those? That's right.
I'm shocked you don't have to be a little bit more specific on the table. It's like 3 of them.
I thought
Yeah.
we didn't pull out one for this.
You're thinking division. Any factoring problem you pull out. Any factoring problem. So, if we divide both pieces by 5. So, step 2. Is this a quadratic? Of course, we've already written down what it is. What is it?
Square.
It's a square or cube problem. And which one is it specifically? Square. Yeah, there's a 2 above it, so it's square. Anytime you have a square or cube problem, you want to rewrite it as 2 squareds. What's the square root of 16? Yeah, you also can use your calculator for that. 16 to the 1/2 power is 4 squared. Now we're ready. But before I plug it into my formula, which I know it's just going to be a bunch of A's and B's, what's my A value going to be, Justin?
B squared.
Just V. Just V. What's my B value going to be?
4.
Thank you. Very good. So, what's my difference of 2 squares formula? It was A plus B and A minus B. So that's all I have to do. Bring down your 5. That doesn't go anywhere. A plus B times A minus B, and that's it.
Hey, are these like formulas going to be on the test Friday?
I'm going to have them on the board.
Okay, good.
I'll put them on the board. Now, in your ACT and end of course, they won't be provided, so hopefully by then we'll have a better feel for them. But maybe by then you'll have seen so many that you can just kind of jump to the answer anyway. We still have another minute or so before we're going to go, but we'll take a break. Y'all can just chill for a minute. All right, number 7. Step 1 of any factoring problem. Nick, what is it? Step 1 of any factoring problem.
7.
Thank you for listening and not talking to Stephen. That's right. Do they have anything in common? No. Step 2 is what, Mackenzie? What is step 2?
What, that?
Jalen? Yeah.
See if it's a perfect
Well, first off, is it a quadratic, right? Is it a quadratic?
No.
No. Is it a perfect square or cube? Yes, it is. So, what is the cube root of 27? Again, 27 to the 1/3 will tell. Okay. Now, is this the sum or difference of 2 cubes?
Different.
Difference. Q, do you have these formulas now?
Mm-hmm.
What's the difference of 2 cubes formula?
Of 2 cubes,
Mm-hmm.
A minus B,
Mm-hmm.
put parentheses, and put parentheses again, A squared plus AB plus B squared.
Very good. So what's our A?
U,
Very good. And what's our B?
3.
Also very good. Okay. So all we have to do is plug them in. U minus 3 times U squared. Let's see, AB would be U times 3 plus B squared. 3 squared is 9. And that's it. Once you plug those into the formulas, you're done. What's that? Well, thank you very much. So now,
That's number 3.
okay. Let's do number 3. That's correct. Number 3 is synthetic division. And how do I know it's synthetic division? That's right. Has everybody got this written down? Who wants it? Okay. Now, to save space, I'm not going to write the problem. You've all got it in front of you. Number 3. What goes in the box? Saul, what goes in the box? Yep. Very good, sir. So we start with our highest one, which is n cubed. How many n cubes do we have, Shuck? What's the number in front of n cubed?
What?
What's the number in front of n cubed?
6.
6, there we go. How many n squareds do we have, Dalton? How many regular n's do we have, Brooklyn? Very good, excellent, good catch. And Taylor Mitchell, how many numbers do we have?
How do you get that?
Alright, so you see how it started with n cubed? So you go down by 1 power of n every time. We had 6 n cubes, 19 n squareds. How many regular n's did we have? Look at it.
That's a weird
None.
-9.
Sorry,
You don't have these.
I'm not.
What is that?
-9.
That's a French negative 9.
Is that really how you do it?
I don't know.
Where?
Matt, what's the first step to a synthetic division problem? Very good. Bring down what's right there. What's the next step, Corey?
It's 6 and 19.
What do I do?
You got, it's, multiplying 6 and 19.
6 and negative 3. Then I add. Then I multiply again. Before I go any further, does anybody have a question about where I got any of these numbers? Then I add. Then I multiply again. What does this 0 at the end tell us?
No remainder.
No remainder. So if we started with n cubed, what is our new polynomial going to start with, Taylor Mattingly? N squared. So 6n squared. Now we're just going to go down by 1 power of n every time.
Plus 1.
Plus 1n
Minus 3.
minus 3.
So why don't we start at n cubed?
Because you see how number 3 says you're dividing by n plus 3? But did you notice the only thing we dealt with was the 3 in the problem? We didn't actually deal with the n. You see that? That's because the beauty of this method is they take that out of it so we don't have to bother. So we kind of already divided everything by that n, which is why it's 1 less. It's a little easier to see if we do it long division, but you guys don't want to do long division, trust me. Okay, so we've now done numbers 1, 2, 3, 4, 7, 5. So the only things left are what, 5 and 9? We'll do 9, then we'll do 5, and then we'll be done. That is everything, isn't it? All right, number 5.
Number what?
5. Step 1 to any factoring problem is what, Jared? What's the first step to any factoring problem? Do they?
Yeah.
What is it? Very good. Let's take out that 3. And if I divide all 3 pieces by 3, what do I get? Miss Elmore?
Are we doing 5?
Yes. Oh, oops. Nope, we're doing 5. My bad. What do I get if I divide all 3? You get what I'm saying.
Squared plus 7x minus 30.
Very good. Very, very good. Step 2, is this a quadratic?
Yes.
Yes, it is. A quadratic is 3 terms with the highest power being an x squared. So you know it's going to be, that 3 is just going to come down. It's going to be some kind of x. let's see. Miss Shively, what does this negative right here tell us?
Shively?
Shively? My bad, Shively. What does that minus sign tell us?
It's going to be a negative.
That means that one of them is going to be negative, and the other one's going to be positive. And what does this sign tell us? Labriette? If they're different, what does this sign tell us? It tells us that the larger number of the factors is going to be the positive one. If it was a minus, then the larger one would have been the negative one. So what are all the factors of 30, Logan? What are all the different factors of 30?
1 and 30, 2 and 15, 3 and 10, and 5 and 6.
Very good. And we know they're different signs, and the bigger one has to be positive. So plus, minus, plus, minus, plus, minus. Which combination adds to get the middle term of positive 7?
10, negative 3.
Very good. Negative 3 and 10. And we're done.
Okay, now we need to do 9.
Yes, we do. Yes, we do. Are there any questions on any of the first 8 before we do number 9? And the last one. And then we'll be done, and you guys can just do whatever.
Are you okay?
I don't know. It really hurts. Thank you for asking.
Do the next one.
Well, we need to talk about it, so I'm just going to do it. But all right, number 9. What's the first step to any factoring problem? Who haven't I called on in a while? Steven. What's the first step? No. What is the first step to any factoring problem? Brooklyn, what's the first step to any factoring problem? Very good. Mackenzie, what do these things have on number 9 have in common? That's right, you can take out a 5. And if you divide all 4 pieces by 5, none of the letters are the same. So that's 12 UV plus 2U minus 6V. That's if you divide all 4 pieces by 5. Step 2, is it a quadratic? No. Step 3, is it a square or cube? No. Step 4, can we factor it by grouping? Yes. So we're going to bracket off the first 2. Now, what do I have to remember on this problem? If this middle sign's a minus, what does that mean for me?
It changes the negative one to plus one.
That's right, it changes the last sign. If it was minus, it'll now be plus. If it was plus, it'll now be minus.
So
Gary?
what do you do? If this is minus, the 6V and 1 is plus.
That's right. And if it had been a plus, you would change it to minus. Whatever that last sign is, you have to change it if that middle sign's a minus. What's common in the first 2 pairs? Katie Rollins? What's that?
Are you talking about like the second?
Right here. What's common in just those 2?
You can like, oh, the U.
The 2 and the U. Very good. You can take out a 2 and a U. Notice that 5 is still hanging out on the outside. So if we divide both pieces by 2 and a U, you get 6V. And 2U divided by 2U is just 1. Do not just cancel and put nothing. There has to be something in there.
Why did you put a parenthesis after 2U? Okay, never mind. I get it. I get it.
Well, is that a 2U or 2V?
It's a U. It's a U.
How did you get the parentheses?
Well, we took 5 out of the whole thing, right? We took 5 out of the whole thing, but we only took 2U out of this piece. So they're separate. So I had to this is what we took out of the whole thing. This is what we took out of this piece. They have to stay separate for right now. This is one of the more complicated ones like this that we've seen. The one tomorrow probably will not be quite this advanced, but I figure, hey, that makes a good practice. Minus. Is there anything common in the second grouping? Who's he going to call on? Taylor Mattingly, is there anything common in the second grouping? Nope. Of course, there's a huge hint. What's the hint? What's the big hint that there's not going to be anything there? Yeah, they're already the same. 6v plus 1 and 6v plus 1. If those are the same, you're doing grouping right. So the only thing left, bring down the 5. So we have 2u 6v plus 1s.
Wouldn't you put the other one to a 1?
Yes, you would. There's an imaginary 1 right there. So we have this many 6v plus 1s and this many 6v plus 1s. So we're going to combine those like terms. So that's 2u minus 1, 6v plus 1s. Is there anything else I can do to that problem? Doesn't look like it, no. There might be sometime. What if one of those had been like x squared minus 9? Then you'd have a difference of 2 squares and you could go further. But this one did not. Look over that review. Is there any questions over any of those problems that somebody would like to see? Tell you what we're going to do. I will give you a grade. If you just bring this to class on Friday, that would show me that you kept it and it was at least available to you to study with. I will give you a 100 homework grade if you just bring this to class on Friday. That will show me that you have kept it and it was at your disposal.